Okay, this is the walkthrough for the Weldment test for SolidWorks. First thing is where to get this test from. If you just Google SolidWorks certifications, the first result should be the SolidWorks certification program. Within this, if you scroll down, you should find the CSWPA-WD. It's a CSWPA-WD, Weldment's Professional. So if you click on exam information right here, it'll be brought to this page, or you can just follow that link right there. And then right here it says sample CSWPA-WD exam. If you click this, you can actually take that test exam, so it's going to send the zip to you. And at that point, that is what we're actually walking through today. Within this zip, you should have this right here. So you should have a PDF of the sample exam, and then you should have one part file that's included as part of this. So I scrolled down in the PDF to where the questions start at about page 16. We'll go ahead and go through this. Okay, so it's saying Weldment profile. Build this profile in SolidWorks, and we're in MMGS. Materials 1060. We've got some dimensions here. Create profile as shown. So let's just scroll down to see if they're needing us to do something else, and they're not. So if you want to do equations for the measurements here for A and B, feel free to do so. Otherwise, for today, we're just going to set these values by hand. But if you want to use equations, go for it. Okay, so what's asking you to do is create a Weldment profile. Note 1, the center will be located at the origin. That's critical, by the way. 2, ensure the profile has pierce points at the midpoint of each external horizontal and vertical line, is indicated by these points right here. Okay, that's what it's talking about when it says pierce points. So all you need to do for these pierce points is create the center lines to the midpoints. So we'll walk through how to do that. So let's look at this drawing. Before we get too far, we've got SolidWorks up and running here. Let's do a reminder refresh as to how to actually set up the Weldment profiles. So for the purposes of what we're doing today, let's go ahead and set up a file location. And we're within the file locations here under the system setups. We're looking for Weldment profiles, which is right there. Okay, so right now I've got two set up. The default one, and then when I took the CSWE, I've got this one sticking around right here. So for the sake of simplicity, we're going to just actually delete both of these, and we're going to add one. Now if this comes up, what's really nice about this is you can do almost all of this from this window right here and set this up as well. So if you guys remember, as part of class, what we need to do is 3 levels of nested hierarchy. The first is going to be a root level folder, and within that we're going to have a separate type, and then within that we're going to have separate more or less like shapes. So we're going to set up a square and a round profile table within that, or a round and square folder within that. So let's go to my desktop. I've got a ton of stuff here, but for now, all we're going to do is just right click anywhere here and go new folder. Let me make that a little easier for you all to see. So for now, I'm just doing a desktop. Feel free to go wherever you want. So if you've got documents, you can do it in documents, downloads, or whatever. It does not matter as long as this is consistent and you can find it. That's the critical spot. So just for the sake of doing something different, I'm going to stick it in my documents. Why not? Alright, so new folder, and I'm going to create this as demo SW Weldments. Okay, within this, I just opened that folder as soon as I created it and renamed it. Now I'm going to put a type. So let's call this demo 1. Within this, we're going to create 2 folders. One is going to be called square. One is going to be round. May not be using both of these today. Okay. Then within this, we can either hit the up arrow to go back a couple, because what we're doing is selecting a folder still. We're going to go here. So here's demo 1, Weldments, documents, and we're going to select again that demo SW Weldments. It's listed right here as the folder. If I hit select folder, you notice everything just got created for me there, which is really nice. We'll hit OK. Yep, that's fine. We'll do that. It may, I don't know if you guys saw, it's asking for elevation for admin and different things like that. So unfortunately, make sure that you do this with admin permissions active if you're using a system at home. If you've got controls, and you may need to have whoever's sitting next to you have control of that. But once you get that created, if we open up this, open that separate location. Remember, I put it under documents. Demo SWPA-WD, we've got demo 1, and then we've got 2 of these folders within this. So this is where these are going to be residing. Okay, so I'm just going to have this open, and then we can continue onwards here. Okay, so we're going to start up a new part, and then we're going to save this as a library profile. So let's go ahead and start up a new part. This is going to be metric because we're in MMGS. Go to old derf mcom profile. Okay. So let's go ahead and start up a sketch, and again, paying attention to the fact it is specifying the center of the Weldment profile will be located at the origin, and we've got some pierce points. So we're looking at 60 by 90. Okay, 60 wide, 90 high, with a 10 millimeter inset for the ID. And then we have some sketched edges here, so we do have to do that as a sketch entity for a sketch round. So we're looking at 60 by 90, 10 on the inside. To make this really easy, let's go ahead and grab this. So quickly set these guys, 60 by 90. Try again. Okay. Okay, so that's step 1. Let me go ahead and turn off everything except what we need to see here. Okay, so we've got 60 wide, 90 tall, and then we're having a 10 millimeter inset. So if we just go right here and go offset entities, select one of these lines here, should select the whole chain because that select chain is selected. I'm going to set that to 10 and then reverse it so we have that inset to the inside. Or you can draw it by hand if you feel like it. Your call. Next, we're going to select our sketch fillet here. Go back to this and see we're looking at R5, 5 millimeter sketch fillet. Okay. And then we'll just select the different edges here. Okay, prove that. So we've got our edges now. Last but not least, let's go ahead and create our midpoint pierces for this. Here's my midpoint. I'm just going to drag the way through, touch that. Hit escape to deselect. Alright, I believe that is a completed profile at this point. Let's go back to the instructions. So now here's our profile. 10 inset. Okay. Okay, next is we're going to name the Weldment WLDM-EX1. Save it to the Weldment profile library so it can be used. Okay, so we'll do that next. To be able to do this, you can, I believe you can save this as a part, but we're not going to be saving this as a part at this point. We're going to be saving it as a library. So we're going to the File, Save As, or File up here, Save As, depending on your setup. And in the Save As type, we're looking for, just think L for library. It's going to be LIBFEAT part, library feature part. Once we do this, it's going to point to wherever it feels like, because it's just designed to point to this design library, and sometimes it'll be a welding profile, sometimes not. But as you can remember from earlier, we actually stuck this in my documents. So under documents, we're going to find this demo SW Weldments that I just created. Within this, we're going to go to the type. This looks pretty square to me, so I'm going to call it square. And according to the instructions, WLDM EX1. Looks pretty close. Not critical that you get the spelling right or anything like that. It's just for reference. But depending on what you're doing and what kind of test you're running, it's probably good to try to keep it pretty close to what it's asking for. Okay, so within that square, again, I'm too deep into that nest. Hit save, and then you can see, kind of hard to see in here, but there's a little L right there. I don't know if you guys can see that. Maybe I'll zoom in and do a cool edit on this so you guys can actually see that. Okay. So now we can actually exit this and just either minimize or close this because we no longer need it. Go back to the instructions. Now it's asking us to open the file a.part, which was part of the original zip. That's going to record or contain some kind of 3D sketch. Using the profile, create weldment part as shown. This is a weldment part. We've got mitered edges on there. Align the center with the 3D sketch, which is this right here, note 1. Okay, use end miter, so we're going to do mitered edges instead of the butt type ends. And we're going to measure the mass. And then we've got a multiple choice question here. Make the part proper material. Make sure that's going to be our aluminum 1060. We've got 4 options here. Hopefully we'll get one of them. Alright, so let's go into SolidWorks, open up that part that we downloaded. So I need to go navigate to where I dropped it. Lots of folders. Okay. So here's that A part as part of that zip file. So here is our 3D sketch. Okay, you can tell because it's a 3D sketch. And it's underdefined too. Yeah, we're not going to fix it. So we're just going to use it as it is. Okay, under our Weldments tab, by the way, if you don't have that, you can right click, go to toolbars, tabs, and Weldments should be there, right there. So select that tab. I'd open up that tab if I was you, if you don't have it up already. Okay, so we're going to add those structure members. So, remember that standard we talked about? Just to be a little bit redundant here. Under my documents, I created that demo SW Weldments. Within this, demo 1. So when I click on the standard, you'll see demo 1. Okay? So that's the demo 1 we're talking about. Under type, so we're going to drill in 1 deep from this, we should have round and square. So here's our square folder. Okay. And then within the size, we have just the one type that we did with that Weldment profile. Okay. Next, we can click on groups, and because we only have one entity here, one sketch, we can just go for it. 1, 2, 3, 4. Okay. If for some reason it was asking for a different kind of corner treatment for something simple, right now if you hover over this, it says apply corner treatment, end miter. We've got one type of end butt joint here and one type of butt fit on the other one. If we uncheck that, you'll notice something about this. It doesn't do corner treatments. See that? It actually just pushes into the material, just as a side note. But we'll go ahead and allow that. Make sure that that option is selected. As a side note, if you hover over the different option here, it should eventually, it takes about 1.5 seconds, show you what that's selected as. So we've got end miter selected. We'll hit check. And then we need to specify our material because I'm guessing that if we go to our mass properties here, this is not going to be correct, I'm guessing. 6704. 6704. But let's change that. Let's see that. Alright, let's go ahead and engage our 1060. Rebuild this, and let's grab our mass again. Okay. 1801. 181. 101. Let's see what we got here. Oh, they were mean. When I didn't set the material, came up as 6704, but when I did it's 18101. That was downright cruel. SolidWorks, not cool. Okay, so let's see if we got it right. So after we set the material, it bumped it to 18101, 18,101 and 0.41 grams, and that's metric again. Let's see the big reveal. All right, we got it. Okay, so that's first question. Okay, question 2, 3D sketch creation, and this is going to be the thing that may or may not be challenging depending on your approach. I'm going to show 2 different approaches to this. One is called the probably close enough solution, and then the one is the as accurate as we can get solution. So let's walk through the probably close enough solution for this, and mileage may vary with this approach, but we're going to show both on how to create a 3D sketch using this. And again, we're going to honor the XYZ plane here. So let's start with the bottom, and in class we typically want to create an upper plane to use to attach these legs to, and then we're going to walk through a second option to do that, but both are going to require creating a top plane first. So let's create a new part. We're in metric land, so let's stay with that. Before doing anything else, we need to look at this sketch and think we've got an upper part of this 3D sketch that's going to be 700 high millimeters off the base. So I think we should start with that first. So we're going to add a parallel plane, 700 mils up. And before we get started, since we haven't done anything else yet, it's going to look like it's pretty high, but that's fine. We'll just leave that. Okay, we can rename this if we feel like it. Let's just call this upper plane for now. Okay. So next is, let's start our sketch down here. So let's turn all the things off, because all we need is the top plane, which we're currently sketching on. And let's look at these dimensions one more time. Pretty simple. XYZ is right here where the origin is, so we'll just dimension out from there, the bottom layer, which we know is going to be 1000 by 1700. We've got a tangent arc right there. Pretty straightforward.
يا ديمة خير وعطاء ويمام نقاء وسخاء يا نجما شع فأبهجنا يا شعلة نور والله يا
Dimensions 1000 on the left.
ديمة خير وعطاء
Then this right here is 1700.
ويمام نقاء وسخاء.
Fully defined, so if we click this, you see we tangent midpoint. Try to drag, and we're in good shape. Right? Exit our sketch. Let's make our planes visible again. That looks much more better. Okay, so let's go ahead and enable 3D sketching, and then we'll do some internal measurement. So under Weldments, we can just start a 3D sketch right there. So depending on the approach, and we're going to go through again the maybe close enough, but again, mileage may vary depending on how we approach this. Let's start with the leg over here. And what we're going to do is to make sure that this endpoint is exactly aligned with this. We're going to create the make on plane relationship. And when we do this, it will stick on that upper plane no matter what. So next is we can use internal measurements. So we can dimension from here to here for that angle, here to here for that angle. They're going to show you why this might be close enough, but you might still have some issues. And again, we're going to go through 2 different solutions here. So let me go ahead and create these guys. And I already messed up. Alright, so we do not want that on the Y, so let's delete that Y, long Y, we want that to go away. However, we do want this and this to be on that plane, so this is good. Alright. Set this on this plane here. You guys hopefully see this coming together.
بذل تعطينا هل هلت بعطاء تسقينا أقبلت فأزهرت الدنيا والبشر توالى يحوينا يا ديمة بذل تعطينا هلت بعطاء تسقينا أقبلت فأزهرت الدنيا والبشر توالى يحوينا يا ديمة خير وعطاء ويمام نقاء وسخاء يا نجما شع فأبهجنا يا كونة نور وضاء يا ديمة خير وعطاء ويمام نقاء وسخاء يا نجما شع.
So there's a reason mileage may vary with this, and I'm going to show you why. A couple different approaches to take and things to consider here. So let's start with, because all those are in the same plane. So in theory, if we look at the measurements here, we're looking at 100 degrees from the outside. If you do the math, the internal measurement should be 80 degrees for both of these. This is only pertinent to this other corner, this corner where it starts with the origin. These are 90 degrees right here. So let's start with the back corner first. Right? So I'm going to measure here to here. 80. Then we're going to do like exactly the same like this. That line to that line. 80. Okay, and we'll grab that. Okay. And we're going to do here to here, and we're going to make that 90. Same for this to this. Okay. And now we hit not a snag, but we need to get something to measure these off of because we don't have anything. So we can either do it externally or internally. Just for fun, let's go ahead and do it externally. And then we'll activate measurement. Put that in here, and we'll do 100. Alright, now we just need to connect the dots, right? And bear in mind when you do this, because it's 3D sketching, it's going to do something kind of strange. If you try to do a arc with this, it starts working, and then you notice that's not the right plane, so you hit, of course, I'll just hit 2. Well, you can see that it doesn't want to work for a couple reasons. Let's see if we can force it to that plane. So in theory, we should be running XZ. And you notice it doesn't quite want to behave. So let's escape out of that tool and just grab our arc tool. That's more better. Last but not, always last but not least, right? Like that tangent, and we're fully defined. And you're thinking, oh wow, that was really easy. This is easy cheesy. And that's why we're talking about how easy this is, the giveaway test. Unfortunately, it's not that easy. So let's exit this. We're going to measure all these sections and see how close we got. Alright, take your time with this. 1, 2, 3, 4. 1, 2, 3. And grab that arc right there. Grab these legs. Alright, huzzah. There we go. Those are all sections. 13919. I've got a little cheat sheet here. 139, what the heck? Okay. So, there is a reason I say this might be close enough. On the test, you may be able to get away with using this methodology. However, you notice that this is not exact. This is not exact compared to this 19 blah 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 58. So let's walk through why. So let's go back into our sketch. You notice it's fully defined. But let's take a look at it from the top. To me, that looks like a 90-degree angle. In fact, if we pull this up right here, there's making some assumptions. It doesn't specify, but I'm guessing what it's doing is 90 degrees here, and here, and here. So let's measure between here and there. if you can see that, but it is not 90 degrees. It is 90.07. Just to add awesome to it, if you can see that, but that is 90.07. It is not 90 degrees angle because of the fact that when you measure internally with 3D dimensions, it is going to have some funky stuff going on. Even though everything is fully defined, it still is measuring to the interior of itself, which is why there's a slight deviation from what actually is dimensioned here. So there's a couple ways that we can kind of overcome this. So let's discuss a few options here. Delete that. And what we're going to do is actually delete this dimension here. And this dimension. Let's see. So right now this is free to wobble around. Excuse me. So let's go ahead and I'm just going to delete that corner right there. Now let's go ahead and drop in 90 over here. Let's force it. Okay. So you notice something that happened when we did that. We went back to fully defined. So let's measure this to here. Let's see if this is 90 right here. 90.08. Hopefully you guys are seeing the issue with this point. Exit this. So here's our bottom sketch. Let's go back into this. And we've got that angle right there. But you notice something about that too. We've got the 80 degrees there, 80 degrees there. Let's look at it from the front. That looks nice and lined up. Let's look at it from the edge. Left side. You notice something about this. I just clicked on the left view, so in other words, we're rotating it to the back of my model, looking at it from the left side. And as I zoom in, you'll notice something. This line and this line are not collinear. Let's look at the other set of lines. These ones are also not collinear. I don't know if you see that, but this is the issue. That's why it's not quite lining up properly. So what we can technically do is we've got this measurement right here and this measurement, and these two 90s are locked in. So let's delete this big 80 right there. Okay, so now this edge right here is floppy. Okay. So let's drop in 90 degrees on this. Alright, now we're back to fully defined again. And let's do the measurement from the left again. Okay, notice that those two lines now are nice and lined up. So let's see if that made a difference. Alright, unfortunately I cannot select everything in one go. I have to exit the sketch and select our measure, and we'll just do top. Let's see, so 13921.43. Okay, so we got closer, but still something is not quite right still. And again, that has to do with the internal geometry of how it measures these angles from one entity to another. There are cases when you can do a side corner where it's 90 degrees in both and measure off of that, no problem. But when you've got an internal measurement from here to there, and then you got an internal measurement from there to there, as it were, in other words, from this line right here to this line right here, or from this line right here to this line right here, that kind of intersect each other, that's when you run into this issue where it's so close, but it's not quite right. So the thing is if you are running out of time and you have to just remember how to do that, that's fine. For the most part, you probably should be getting pretty darn close, and you can kind of go from there. But however, I'm going to show you the method that will lock this number exactly to the decimal. So I'm going to leave that open for a minute. And again, it's fully defined. Everything in theory should be running, right? Here's the issue though. Let's take a look at this. You notice that that is 80 degrees, right? But let's measure from here, this plane, which should be measured from here to here. I'm going to use my measure option. Notice the angle, 75.89. So in other words, something is not quite right when it comes to measuring from this to that angle right there, in either direction. In other words, if I click here, edit the sketch itself. Oh, I'm already editing a sketch. Let's measure from here to here. You notice the number, 80.15. So, in other words, there's some inconsistencies depending on how we want to go about doing this. So, we're going to set the same thing up, except this time we're going to approach it a little bit differently by using planes. So, when in doubt, plane it out. So here we go again, same exact process. So we need that top plane first. So let's go ahead and create that. Everything's already plugged in because I used it last time. There's the 700. And we're going to start exactly the same, except what we're going to do is create construction lines, because construction lines are our friends, as always. So first thing is, let's create a sketch on the front plane here. And what we're going to do is create a line that looks like this, and a line that looks like this for construction geometry. Let's go ahead and make this one 700 so we have a frame of reference. Select that out just a little bit. Then let's go back in and create a true orthographic perspective of this. I'll go ahead and dimension this angle to 100 exactly. So now, fully defined, we've got a construction line at that 100-degree mark. Okay? You know what? Let's put this way over there so it doesn't get in our way. Okay, and now we're going to do the same exact thing, except we're going to do it on the right plane. In this case, we know the base is 1,000. So let's go ahead and type in 1,000, not 100. And now we're going to do the same thing. Let's go ahead and create a angle here of 100. If we feel like it, we can push it into that plane. I don't think we need to, because we're not going to be using this for any geometry other than creating a little encapsulation box for our thingy here. So let's take these planes and just expand them a little bit. Except I don't want to see this plane. I'm going to make that not visible, and I'm going to make that not visible. I don't want to see these two planes. All I care about right now is the bottom and these sides, and you're going to see why in just a second. Okay? So let's create a type of system. We're going to create a separate plane here using reference geometry. The first one, our reference is this, and then we're going to click on this line right here. By doing this, so you can see what we're doing is creating a perpendicular relationship with this right here using this. So it takes this plane, rotates at this. So by doing so, we have our back edge. Okay. All right. I think I forgot something here, didn't I? I sure did. Let me add this sketch real quick because we need one more dimension. Right there. All right, set that to 100. The internal angle right there is going to be 80, right? Exit that. So now we've got this option. Right plane for our source, plane. And then we're going to use this as our second reference to coincident that out. Okay? Approve that. We're going to expand it. Okay? We're going to select our right plane again. Select reference geometry. We're using this again as our coincident. And that should start looking sort of like the shape we created there, right? Okay, so we're creating like a box. By doing this, now we can take this sketch, make that invisible, that sketch, make that invisible. So now all we have is kind of like a little box to put everything into. So in theory, we could do everything in one 3D sketch now. So let's start that sketch up, make it move it from the top. Let's go ahead and take our top view. And we're going to start on the origin and then go out from there. So we'll start the 3D sketch right here. Under Weldments, you can just select the 3D sketch right there. Make sure you're in 3D sketch before you start, otherwise you're going to have to come back and do this, or you do two different sketches, kind of the same at this point. So let's go ahead and drop that into place. That's going to be 1000. Grab this edge right here. We're just dropping it along here. Kind of hard to see, but we're good to go there. It's going to be 1700. All right. Kind of drop an arc into here, except that's not the right plane, so let's hit tab till we have the right plane. There we go. Something like that. Last but not least, let's drop our line right there. For that to create our tangents. And this needs to be along X. So that line right there, we want this to be, it's similar to using horizontal, but remember in 3D Sketch we don't have horizontal vertical relationships. As you can see right there, we don't have those, but what we do have is this. We want this along the X. So as soon as we click that, notice everything shores up and we're fully defined at this point. So I can't move anything more, and now I can keep going with the sketch. So unlike before, we're going to set this, instead of just having a point to point, so notice we're going to draw a line from here up to this plane and lock this into that plane, that end point. We're going to do that and then some more. So let's go ahead and start in on our origin. Somewhere over here. It's not even close, but what we're going to do is close this, and we're going to create our make on plane relationship like we did last time. Except this time we're going to do something a little different. Now we're going to take this entity and we're going to use the same exact relationship, make on plane. Okay, and one more time. So by doing this, what happens is, you can see when we're now fully defined, everything is locked up to the actual sketched planes that we defined here and here. So now this is true to the dimensioned drawing as it drew, as it was presented to us right here. Okay, so again, this is there's a good chance that if you did it the other way, using internal geometry for the 3D sketch, it would probably get you close enough, but just bear in mind this is what SolidWorks is expecting, at least the test is expecting you to know how to do. All right. Make a plane here. Make a plane there. Okay. So by doing that, we've got our endpoints all lined up. Let's create one more. Okay. So what we could do is depend on that 90-degree angle, but we're going to create an additional plane here. We're going to roll this back. Let's create a plane based on the right. And then we're going to do a 1700 space on this guy. that bigger. Okay. Turn the sketch back down here. This. Now we're going to take this and this and put that on that plane. So here is the fully defined true framework of what SolidWorks is expecting when it comes to these measurements. Simple little problem, but a little bit exaggerated is kind of the approach here. Okay, so everything is on plane at this point. If we move to our back view, left view, as I scroll in, you can see that everything is nice and lined up now. There's no discrepancy between those. But most importantly, let's lock up the rest of this. So we'll go ahead and connect here to here. And we'll do it again. And again. And I'm just going to connect these like we did prior. Make sure you are on the right plane. There's our plane. Make this easy. We can coincidence that up. And let's make that tangent for sure. Okay, same thing for this. And now we are fully defined. So, see if this works. Sometimes if you do everything that's really sketchy, you can do this all in one go. Oh, I got something else in there. So we're going to exit the sketch, look at these line entities, and let's measure again. Actually, before we do that, let's measure this angle right here. Right there. 90 degrees. Overdefined, but we are in good shape. Measure this, 90 degrees. So you can see everything now is in good shape. And that was the issue. So if we exit this, go ahead and activate our measure tool. Grab the top edge. Grab the 4 legs. And grab the bottom edge. Okay, so our answer key. 13924.258. 13924.58. So why I say the mileage may vary between those two different approaches is if you're in a rush, and this is a lot more time consuming to do this, but this will get you exactly what they're expecting in some cases. Make sure you read the question first. And that is the solution for answer 2 if you want to be exact. Moving on to question 3. So let's use Weldment, and we're going to use 1060 as our material. Apply material, great. And then we're going to use a Weldment profile that we first started with. And line the center. Okay, so that's a good thing to do. And we're going to do an end but one corner treatment to all the segments and measure the total mass. Okay, so it's asking us to do wrap around like that. And you can see right there what it's expecting. So you're going to have to play around with the sections and how they're grouped a little bit, but let's go for this, okay? All right. Still have our 3D sketch active. Make it a little bit easier to see. Let's make all those planes not visible. One more plane to go. Okay, so here's a nice 3D sketch. Under Weldment structure member, again, we have this all set up, so we are good to go. So in this case, we're going to start with this leg, and then we're going to finish over here. So we're going to start here and then wrap around. Section 1, 2, 3, 4. So you can see right now it's a mitered finish on these edges. So to do this, we're going to use this option right here. Okay. And let's see if that is doing what we're expecting it to do. Okay, it extends all the way out. You can see where this is swapped. So let's clear that and start here instead. Let's see what this does. 1, 2, 3, 4. So still see that's not quite correct as to what we're trying to do. Let's try it again. Let's go the other direction. Let's see what happens. 2, 3, 4. Okay. In other words, if you can see the preview, that's going to be on that side, which is not what we want either. So at this point, you're thinking, how many times do I have to mess around with this? Well, easiest thing to do is just go ahead and get this done like this. Okay. So that's more better like that, right? You can see that edge right there sticking out. Now let's go back to this corner treatment right here. You can see in that drawing that extends all the way out, so let's do this. Try that. Okay. So it's kind of hard to see there, but this is what they're expecting. Open tube there, and then this terminates as it hits this wall right there, that inside edge. Okay, just like that. Okay, while we're in it, let's go ahead and create the second group. And it's going to be the same exact thing, except just on the upper level. Okay, so first thing is we have to create a new group. So, doop, 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 doop. Okay, is that correct? Let's try clicking that instead. Okay, you notice what I just did? Hopefully that makes sense. I just hit the type of alignment right here. And I think that's going to do it. Let's compare the image. Yep, we're good. Just throw in 1060. Rebuild, and let's grab a mass. 77001.15. 77001.15. That wasn't too bad. Okay. So that's question 3. Just make sure you make the weldments look, the structure member look like the image it's providing. That's the key for that. All right. Use these images to answer question 4. So they're asking us, it looks like, to stick in a vertical leg creation. Let's see, add the 4 vertical legs like this. So again, the image is going to be key as to what they're wanting you to do. Use a center, okay, of the weldment. There's a 0 gap, so we're not going to do any welding gap. And the vertical axis is going to be aligned with the number 1 segment aligned, which is the bottom edge. So we're going to use this bottom edge for the alignment profile. And measure the total of all the segments, and we've got 4 choices here. Okay, so let's go back into this, and we're going to just edit the weldment profile that we were already creating. And by doing this, let's look at what it's expecting, I guess. Subsections right here, right? So let's see if we can add it like this. So we're going to create a new group. 1, 2, 3. Doesn't like that. New group. 4 new groups. Awesome. Okay, so if we look at this image, everything looks like it's aligned to the center of this. So let's go back and backfill this. So we're going to go to group 3. Go to the bottom here and go alignment. If we click this option right here, what we can do is click that right there, and then we're going to do a vertical axis align. Hopefully you can see the difference there. Okay. Now we're going to go to group 4, which is this one. Same thing. Alignment. That line right there. And switch the axis of alignment to that one right there, vertical. Okay, next group. Vertical. Then the last one, alignment, center line right there, and their vertical axis. So everything is done. You should see something looks exactly like that. Except you already see an issue here. See the fact that we have overlaps? So this may be the case where we want to use a separate group. And we'll see what we can do with that. So let's go back into this. Edit this. And we can look at corner treatment if we need to. Let's see. Oh, we're still pushing up and in because we're going all the way to the center profile. But you notice how these are happy, these edges right here? But these ones are not. So let's take a different approach. Let's delete these groups right here. Then we're going to create a second set. So let's create a structure member here. And we're just going to do this as we go. See if it'll let us to do another one. Nope. Okay. But you can see it ends up being the same result. So we are going to have to come back in and trim this. According to this right here, we need to trim these edges to be able to finish this. So it does not matter on how we approach them. You can use one group, you can use two groups, but let's go ahead and finish what we were doing here. Group with this, alignment, vertical, and one more group. Like to here, the vertical. Okay, so that's not bad, but now we have to do a trim. So we'll come back in here. We have to trim all these up to get the proper mass, because right now if we grab the mass properties, we're looking at 9, blah, 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 34. If we pull up our cheat sheet, we are off by a bit. So let's close this, and we're going to use our trim. Okay, we are not going to use anything for the gap. So that should do it right there. Since it's pretty simple, that should be it for that edge. That looks more better. Let's do it again. Okay. I'm going to trim up to that. And that. Much better. All right, two more to go. Last one. So as you can see, that and that look about right. Let's go grab the mouse and see how we did. 94379 to the dumber. Yep, awesome. Okay. All right. One more question here. So that is question 4. Images to answer question 5. Modify the corner. Okay. What is selected mass? So we're only doing one edge of a corner treatment, which stinks because we have to undo all the work we just did, because you have to have the same group if you're going to have a 3-way mitered edge like that. Awesome. So let's go back into this. Except the good news is we only have to do this once. So let's edit this. Here's group 1. We're going to delete that. Leave everything else together. Trim extend. Okay, so we're going to delete that. Now let's go back into the original group. Edit this. We're going to add one more group. Alignment's going to be center, vertical. Okay. So that's the first thing. But now we need to go back into this. And let's see the question one more time. Just the top edge. The bottom edge looks good. We can come back and actually clean it up if we need to, but let's address this three-way mitered edge. Okay. And it looks like it's saying, what is the mass of the selected vertical leg? It's not pointing at it, but I think I know what it's getting at because the number is way smaller. On the test, it'll actually have you isolate this, but we're going to walk through that. Okay. So let's do a mitered edge on three-way there. Remember, this has to do with how we cut this this condition right here. So let's go into this again. And we're going to click on this right here. Trim order like this. And we're going to accept this, and we should be good. I'm going to do that one more time. So when I was in this edge right here, so I'm in here, I just click on the little pink option right there. What it was like before, it looked like this. So these two get the treatment first. But when I click on this, all we need to do is set these to exactly the same trim order, which means it's going to have the same corner treatment for all three to bring together. And then that's how we finish that up, which I think looks acceptable to what they're asking for. Let's isolate this. Going through the mass with 4602.09. I think we are within the ballpark of what it's asking for by 0.6. And if this is having an issue, I don't see a gap, but let's go ahead and trim it anyway. I don't think that's an issue. Okay, so we'll do that just to make sure. We'll have a gap of 0. I don't think that's going to make any difference, but we'll find out. 0.3. So in other words, this is the method to get close enough, and that's it. So for question 5, I think that's about as accurate as it's going to get right here for that kind of treatment. Any questions? Let me know.